have a look at this equation. How would you solve this equation in order to find out the value of x? So let's see how to solve equations which are reducible to quadratics. This is how a normal quadratic equation looks like. I want you to notice one thing over here, that this power of x is exactly half of the other one. So whenever you have an equation in which one power of x is exactly half of the other one, then by making some suitable substitution, we can always reduce that equation to a quadratic one. For example, if the examiner asks you to solve this equation, which is clearly not a quadratic, but if you look carefully, this is x squared, which is exactly half of x raised to the power of 4. So if I make some suitable substitutions, I can reduce that to a quadratic. So I'm going to suppose the lower power of x, which is x squared, as u, and then if I take square on both sides of this, I'm going to get u squared equals to x raised to the power of 4. Now I'm going to apply these substitutions into the main equation. Now x raised to the power of 4 was equals to u squared minus 5 x squared was equals to u, so x squared, I'm going to replace x squared with the u, and plus 4 equals to 0. After that, I'm going to factorize it the way we normally do, and then we're going to get two values of u as 1 and 4. Now we're going to change it back to the x as that of the original equation. So if you recall, u was equals to x squared, so I'm going to replace both of these values, both of these u's, with the x squared. So this is going to give us x squared equals to 1 and x squared equals to 4. Now by taking root on both sides in order to find out the value of x, I'm going to get plus minus 1 for one and plus minus 2 for the another one. So these are the roots for our equation, which are minus 2, minus 1, plus 1 and plus 2. Now you can go back to the equation which I showed you earlier and try solving that by using the same technique.